Causes of weather. The following are key factors that cause weather. It's important to remember that every physical process of weather is either accompanied by or is the result of heat exchanges. The unequal heating of the Earth's surface causes differences in pressure, which in turn affects altimeter settings. On weather maps, lines that connect points of equal pressure are called isobars. These isobars show pressure contours, giving us a picture of pressure differences. Remember that closer the lines, stronger the wind. Next, the three key forces that affect winds. The pressure gradient force. This force causes wind to flow from areas of high pressure to areas of low pressure. Because of this, wind tends to flow perpendicular to the isobars. The Coriolis force. Due to the Earth's rotation, winds are deflected to the right in the northern hemisphere. This force is at a right angle to wind direction and becomes stronger with higher wind speeds. Its effect is more pronounced at greater altitudes, above approximately 2,000 feet above ground level, where surface friction doesn't slow down the wind. At these altitudes, winds tend to flow parallel to the isobars. Friction with the Earth's surface. As winds near the ground, friction slows them down. Since these winds are slower, they are less affected by the Coriolis force. This causes the pressure gradient force to become stronger, making the wind flow across the isobars instead of parallel to them. This friction is the reason why winds are generally stronger at higher altitudes. The troposphere, tropopause, and stratosphere. The lowest layer of the Earth's atmosphere is called the troposphere. On average, it reaches up to about 37,000 feet in mid-latitudes. However, this height varies. At the poles, the troposphere extends up to 25,000 feet, while at the equator it reaches up to 65,000 feet. At the top of the troposphere, we find a thin boundary layer known as the tropopause. Temperature and wind can vary greatly in this region. The tropopause is associated with a sudden change in the rate at which temperature decreases with altitude, also known as the temperature lapse rate. Above the tropopause is the stratosphere, which has a much lower moisture content and typically lacks clouds. In this layer, temperature changes only slightly as altitude increases. Next, we have the jet stream. This is a narrow, fast-moving river of air located near the tropopause. It follows pressure ridges and troughs in the upper atmosphere and typically blows from the west. The jet stream's winds reach speeds of 50 knots or more. In the summer, it is weaker and moves farther north, while in the winter, it becomes stronger and shifts farther south. Air masses and fronts. An air mass is a large body of air that has uniform moisture and temperature properties throughout. A front is a boundary between two air masses that have different temperatures, humidity levels, and winds. When you fly across a front, there will always be a noticeable change in wind. Wind shear, which can pose a threat at lower altitudes, is something to watch for around these fronts. With a warm front, low-level wind shear is a concern just before the front passes the airport. In the case of a cold front, the most critical period for wind shear occurs just as, or just after, the front passes the airport. Remember, the threat of low-level wind shear occurs just before the warm front passes the airport. With a cold front, the most critical period for wind shear occurs just as or just after the cold front passes the airport. Lastly, frontal waves and cyclones, which are areas of low pressure, often form along slow-moving or stationary cold fronts. Squall lines, which are narrow bands of strong thunderstorms, typically develop ahead of a cold front.